Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the construction and structure of Zener diode. How the Zener diode is constructed and what are the construction structure, what all the construction consists of, and how it is going to work. Okay, construction. What does the construction means? What all the equipments we have, specifically in what way the Zener diode is designed of. Okay, the diode, which is specifically consists of a p-type and an n-type. The semiconductor is nothing but a system or a component which conducts electricity to a certain point, and then it acts as a insulator, that is called the semiconductor. Here, this Zener diode is a semiconductor device where it contains the p-type and the n-type material, where p-type is majority of holes, where n-type is majority of electrons. Okay, here p-type is connected to an anode, is formed to be an anode, and then n-type is formed to be a cathode. Okay, here in this Zener diode, that is PN junction diode, is a heavily doped. Normal PN junction diode is a pure form of semiconductor where we don't have any doping in it, whereas in the Zener diode we are going to dope it by an impurity. Okay, heavily doped PN junction diode to form a Zener diode. Okay, and then we'll have a depletion region. How the depletion region forms? When the anode and the cathode is connected to a positive, when the anode is connected to a positive terminal and then cathode is connected to a negative terminal, when the supply voltage gets increased, the holes in the p-type and the electrons in the n-type gets recombinated or attracted together and forms a layer which in between the p and n-type layer is called a depletion region. In this Zener diode, we have two types of region called two types of breakdowns called avalanche breakdown and a Zener breakdown. Okay, fine. Now we are going to see about the symbol. How does the we can in further discussion we will be reading will be knowing more about the avalanche breakdowns and the Zener breakdowns. Now we will see about the symbol. The cathode, which is Z-shaped bend. As I told you already, the cathode is connected to a Z-shaped reversed compared to normal diode. This, when the Z is incorporated, it is specifically designed to work in a reverse bias condition. Operation, how does it operates? Designed for specific reverse breakdown region, as I told you already, a reverse breakdown region. How does the packaging types, how does the system, the Zener diode will be packed off? Through holes, surface mounted, okay, DO41 and D035. How does the structure contains, as I told you already, the p-type and the n-type. Okay, we have a Z-shaped bend which is specifically designed for reverse condition. The depletion region is formed when, because when is that is when the p-type is connected p-type is connected to an positive terminal and the n-type is connected to the negative terminal. When the supply voltage gets increased, the p-type acts in the forward bias condition and the n-type n material acts as a reverse bias condition. When the electrons and holes gets recombinated, a layer formed in between the p and n type is called a depletion region. Okay. The working principle, breakdown mechanism, as I told you already, we have two types of mechanism called Zener breakdown and an avalanche breakdown. Okay, this avalanche breakdown is specifically will work in a forward bias condition. Okay, where we don't have any Zener voltage. See, specifically then the Zener voltage will be of 0.6 until okay, the 0.6 reaches, this Zener diode will work in a avalanche breakdown. See here we have mentioned it, avalanche breakdown, whereas that is voltage of Zener is less than 5, which is less than 5, it will work in an avalanche breakdown where the voltages will get increased and the current also will get increased in a minimum value. Okay, whereas in the Zener breakdown, once the greater than 5 volts or a 0.6 that is voltage of Zener were increased greater than 5 volts, it acts as a Zener diode where the voltage and the system gets breakdown and it acts as a Zener diode where the voltage and the current gets increased drastically. This is the difference between the Zener breakdown and an avalanche breakdown. Zener breakdown is a heavily doped junction where the voltage is greater than 5 volts. Where avalanche breakdown is a lightly doped junction where we don't give any will be giving out minimum voltage to it in the forward bias condition. And whereas in the Zener breakdown we have tunneling effect, whereas in the avalanche breakdown we have impact of ionization. Quantum mechanically phenomenons, here avalanche multiplications takes place. Okay, here mixed breakdown. How does this mixed breakdown happens? Between the 5 to 6 volts we have, right, that combination of both mechanisms happens. Okay, below 5 the avalanche breakdown occurs, and above 5 to 6, maximum it is 6, it will reach to a 6, that time it will act as a Zener breakdown. In between this 5 to 6 both the mechanism occurs. Okay, how does the operation principle is that maintains constant voltage in a reverse breakdown region. As I told you already, after 6, at 6 the the current gets increased drastically, whereas in the avalanche breakdown it is will have a minimum amount of voltage and then also a current will be increased. Okay, thank you.